Friends, today we are going to see about multiple in and multiple output, that is MIMO systems. Let us see about this in detail. So in this today's content we are going to see about massive MIMO definition and multiple user versus single user and massive MIMO potential and TDD or FTTP and what are the limitation and what are the research problems and what are the channels and codings. So let us see what is massive MIMO. So massive MIMO is something that it's a large scale antenna, or you can say a very large scale MIMO system or hyper MIMO or full dimension MIMO or agros. So it is something that multiple input and multiple output, where it has multiple number of transmitter and multiple number of receiver. So it is a new research field where the base stations are equipped with large number of antennas as compared with the previously considered system. So this is an example of massive MIMO definition. So here see in this building many number of transmitter antenna has been attached so that the data has been transmitted parallelly. Next, let us see the difference between multi-user versus single user. So here the single user where the multiplexing gain may disappear when the signal power is low and relative to the interference and noise or in propagation. So the environments with a dominating line of sight and inefficient scatters. So in single unit MIMO systems, the system require a complex and expensive multiple antenna terminals, whereas the practical size limitation on the terminals also limit the number of antennas that can be used for multiplexing the gain. So this diagram represents the single user MIMO system, whereas the next is your multiple user MIMO system. So here the transmitter has a number of antennas and the receiver has a multiple output receivers. So it shows that all the effects of uncorrelated noise and fading disappear, and also the intercell interference is reduced. So compared to single user MIMO system, the multi-user MIMO system is effective. So the only remaining impediment in intercell interference due to a pilot contamination. Next, let us see about the massive MIMO potential. So massive MIMO potential is something that increase of data rate, because more antennas and there are more independent data streams can be sent out and more terminals can be served simultaneously. Here each terminals can be given the whole bandwidth. Next is your massive MIMO can build with inexpensive and low power components. So here ultra linear 50 watt amplifiers are used in conventional system and are replaced by hundreds of low cost amplifiers with output energy with output power in milliwatt range. So in massive MIMO reduces the constraint on accuracy, linearity and of each individual amplifier and RF chain. So next is main thing is that improved energy efficiency, because of base station can focus its emitter energy in spatial direction where it knows how the terminals are located. So this diagram represents a single antenna transmission and multiple antenna transmission. So the efficiency is high compared with single antenna transmission, and where with the help of multiple antenna the user can transmit and receive in higher data rate. So next is your reduced interference. So because of base station can purposely avoid transmitting into direction where spreading interference would be harmful. So next is TDD or FTD. We need a pilot signal for a channel state information estimation, but also there is a two problems. First is optimal downlink pilot should be manually orthogonal between the antennas, and this means the amount of time or frequency resources need for downlink pilots scales as a number of antennas. Next thing is the number of channel responses. The number of channel responses must estimate also proportional to the number of base station. The uplink resources need to inform the base station about the channel responses. So the solution is to operate the TDD mode is reciprocal between the uplink and downlink. This diagram represents the operation between the downlink and uplink with FDD and TDD. Next is pre-coding technique. Pre-coding techniques, the main goal is to decrease the multi-user interface and increase the achievable sum rates. And the types is something that linear pre-coding and block diagonalization pre-coding and Tomlinson and Harashima pre-coding and vector determination pre-coding. Channel reciprocity. The hardware chain in the base station and terminal transceivers may not be reciprocal between uplink and downlink. Pilot contamination is something that it encountered only when it analyzed multiple cell Mimo systems with training and is lost when narrowing focus to a single cell setting. So pilot contamination occurs when the channel estimation at the base station in one cell. So next is the distance between the user and base station. So the distance between the user and the base station is closely located with line of sight condition. It means the spatial separation of the user should be particularly difficult. Okay. Next is we still have a user closely spaced but with a base station of antenna arrays. Okay. Next is the increased separation of the user should help to improve the performance, and the spatial fingerprints of 4 users are significantly different. So if you have any doubt related to this Mimo systems, please feel free to contact me. Thank you, students.